Everyone, I'm Won Lee. We have been studying Chapter 4, Estimation. If you understand estimation well, that is great because you prepare to study Chapter 5, Hypothesis Test. And estimation, test hypothesis are main part of statistic theory. So now, today's topic, how to decide sample size. Okay, this is the final section of chapter 4, estimation. Let's see. All right, here, how to decide the appropriate sample size. The way how to answer to a question, why do you obtain a sample size 900, something like that. This is example, okay? Then when you present your report to some bodies and you get a question like this, then you will be embarrassed, I think. So this part, this section will maybe the question, answer to that question. Okay, when obtaining sample from a population, one may face the question of how to determine the appropriate sample size. It is common knowledge that the larger sample size n, the more accurate the result will be. You believe this? However, one cannot simply increase the sample size because of time and cost restrictions, right? Additionally, it must be taken into account that the sample size is proportional to the population size, capital N. If population is big, then the sample size may be increased, may be bigger. Okay, let's denote the population size as capital N. When the population size is finite, capital N is finite, something like 1 million. Okay, that is finite. The variance of the sample proportion p hat is theoretically given by this way. We studied the sample population p hat. Its variance is like this. But that is the case. N is infinity. But capital N is finite. Then we have call it correction factor like this. Even though we have this factor like this, then it is very close to 1. So we ignore this part. Okay, we ignore this part. But here it is the section of sample size, so we add this part here. Okay, I will keep it a little while. Now, the standard error of p hat is what? Square root variance is a standard error, so square root of this part, this one, should be estimated because we do not know p yet. Okay, but this part, standard error of p hat, should be estimated as like this. I told you before when we studied sample proportion. Thus, 1 minus alpha, 100% confidence interval for P is actually this one with this correction factor. You understand that? Okay. Now, the value which determines the width of confidence interval is this. This one decides the width of confidence interval, right? Confidence interval, width of confidence interval actually 2 times this part. So this one is called sampling error or margin of error. Okay, this is a new terminology, not standard error, sampling error. Get it? All right, then we want to let the sampling error be D0. D0 is some fixed value, say 0.02 or 0.03, something like that. So D0, then D0 is given value, and from this equation we can get small n because capital N population size n is fixed. We know the size of population capital N. We may calculate the value of n from this equation when the values, sorry, d0 is fixed given p hat. Okay, we know p hat even though before sampling. Anyway, p hat is some value, and capital N, this kind of three values are given, known, then we can solve what the value of n from this equation. Dramatically, the value of n becomes the largest when p hat equal to zero 0.5. N has the maximum value when p hat equal to 0.5 from this equation. We may get the sample size enough. You may get the sample size enough. Okay, it is not strict, you know, value. So if you find out n equal to 398 from this equation, okay, from this equation, we take sample size n is 500. I like that because some sample value, real value, observed value is destroyed or biased, or we have to get rid of that kind of a sample value. So we may have enough sample size, 500. Therefore, from here, p hat equal to 0.5. 0.5 is here, g alpha over 2, this value is 0.5, 0.5. So out of square root 0.5, g alpha over 2, square root 1 over n, square root capital N minus n divided by capital N minus 1. This one, this equation comes to here. Okay, we can get the appropriate sample size from this equation. Get it? Note that we used to use 95% confidence level, then G value is 1.96. This is a reminder. And if the population size is too large, that is, say, what? 100 million, capital N. That is too large, okay? Then, even though you have a, what sample size is 1,000 or 100, 10,000, then this value close to 1, right? When capital N is 100 million. Then we may use this part out. So this equation, simple equation, if population size, capital N, is too large, then we ignore this part. So from this equation, we can get what? N, right? Because D0 is fixed, some value, given value. G alpha over 2 is, say, 1.96, then we can get N. Now, if the population size is capital N and the sample size is small n, we can also calculate margin of error, D0, right? From this equation, capital N is, say, 10,000. Your sample size is 500. Then you can calculate, and the G value 1.96, then D0 will be calculated, right? From the above formula, from this formula. Above formula is this. For example, when you obtain 900 size sample out of too large n here, you may calculate the margin of error of 95% confidence level as 1.5, 1.96, and square root 1 over 900. This is 1 over 30, 1 over 30, right? This value is 1 over 30. So the value of what sampling error is 0.0327. Let me answer the previous question, but it rarely happens that when someone asks you, why is your sample size 500? or 900, that kind of question, while presenting your report. But you will be embarrassed because, that is very rare question. You have no choice to answer with sampling error by the above equation. You have to think about this kind of equation and see, okay, 900, okay, then what? Sampling error is 0.0327. I think in this study, the sampling error 0.0327 is enough, okay, enough so that I took sample size 900, something like that. That can be a good answer, and everybody understand that. But this is a little. This kind of question is a little ridiculous one, but sometimes may happen. Okay, this is the end of chapter 4. Thank you so much so far. Bye.